And then we are going to share. And we are officially starting. Okay. I don't mean to yell too loud, but I hear some of the recordings. I hear some of the recordings and it sounds like I don't speak loud enough for the people on people that join us virtually. So I'm going to talk about a couple things last week. Today, we're going to talk about this neat subject called change detection. As you can imagine, change detection is just ways to measure change. Now, I'm going to talk about all the different ways that I've measured change detection, even something called like a Descartes index or differences or whatever. So I'm kind of interested in that, looking at kind of your opinions of things. And this is going to start getting into some of the geostatistics that we look at, things like spatial mean, spatial median, movement. Because right now we're kind of sitting in this space where we're just looking at tables and basically mapping them. And most of the calculations that we can do can be done in Excel, for lack of a better term. So last week I posted everything. I made a challenge to do some age grading, and someone actually did it. So they went and age graded everything, so they don't have to take the midterm. So just make sure that person reminds me, because at the end of the semester, I don't want to calculate a zero. No, I put it in there. But it was really neat. It's really like robust, because you have to do the age specific death rates, and then you need to normalize that. Yes.
Challenge for one person. I didn't know.
It was up to two.
Oh, up to two.
Up to two. So you got one other person who turned it in. You probably put more work into doing that than doing the midterm, but I thought it was pretty neat. And you'll see the movement of the death rates, because I focused on that area because the northeastern part of that area is like Moore County, where there's like a lot of retirement communities where you'd expect to have higher death rates, raw death rates, but then they move to the other side of Fort Bragg when you normalize things. But you run into some caveats with normalizing, where you're going to have like zeros and ones and all these other kind of strange numbers, but really, really small numbers. And we call this the small number problem, because if we go from like 1 to 2 and calculate death change rate, that's 100% change. That's a lot. Like it doubled. It didn't really double. If something went from 50 to 100, yeah, I'd be concerned. If something went from 1 to 2, I'm not as concerned. But when we calculate percent change, that they still behave the same way, quantitatively and mathematically. So I want to make sure we kind of think of maybe some clever ways to tease those out. Or today we're going to look at change detection, where we really want to just look at 1 year to the next, or what are ways that we can kind of get bigger numbers that we can work with, and work with larger cohorts of numbers. So I talked about that. Raw values, they don't have a lot of value, except if maybe we're looking at like resource allocation, looking at people live. Reading 1, exercises 1, 2, and exercise 1, they're all kind of due. So everyone can see that I've been going through and grading stuff. And so kind of starting next week, we are going to kind of work on, I'll start grading stuff when they turn in, because last week we started exercise 3A. And then if you kind of looked at exercise 3, it's got 2 parts. Some of the stuff that we did last week with normalization, and then 3B, where we're going to do some change detection this week. So we're going to look at some change detection with COVID rates, and then maybe get into exercise 3B in the second half of class. And so we'll kind of look at that. Also, this time, in 10 hours from now, I'm going to be at the airport, because I had a death in my family, so I got to go to New England. So I get away. Hopefully my wife's not on. Okay, I get to get away from the wife and kids, for sad reason, but get away from the wife and kids. Get up to New England, go see some Dunkin' Donuts and all the other good stuff up there. I'll be out of town, so I might not be able to post a recording of anything for a couple of days, because I will be engaged there and I'm driving back I'm flying up, driving back on Saturday, so I'm going to be kind of, my availability might be somewhat limited. So if you try reaching out to me, don't get offended if I don't respond. But I will have this by the end of the weekend. I'll have a uh, recording of class posted here. So today we're going to talk about change detection. We'll talk about the idea of change detection, and then we'll kind of look at a case study where we're just going to calculate change in COVID rates. Because to be honest with you, we started looking at these things, everything's spatially related. I bet you change in COVID rates between two different dates, you can stick it onto a map and see differences in those. And to me, I think some of these phenomena out there, whether it's things like SIDS deaths or ADHD or infant mortality rates, I always think of them as like stochastic phenomena that happen to a single person by more or less chance. But when you put them on a map, you see spatial patterns attached to those, which I think, to me, even to this day, I still find interesting. So we want to find changes across time. Now, ArcGIS Pro has done a really good job about doing time series mapping. So you can do, maps that change from one color to the next. When I started with the GIS software, it didn't really do much of that. So I haven't really gotten too much into that. But things like how and where have the COVID-19 pandemic rates changed over the course of the pandemic? COVID is still a real thing these days, even though we're not shutting down schools and all that other stuff. Where have high school graduation rates changed over a period of time? How have patterns of crime changed a city annexed land? We hear about this term annexation, or where have Dollar Generals been added within a study area? And that's a big one. And this is kind of really interesting one here. Dollar Generals, I think, are really neat. One was built right around the corner from one of our houses. We rent out a farmhouse in northern Greensboro, and they built a Dollar General there. No one wanted it there. Why don't people want Dollar Generals there? Because it's right across the street from the Lowe's, which is a lot more expensive. Lowe's supermarket. Why don't people want Dollar Generals there? And then the next stigma, like what type of stigma?
It's like negative.
Negative, yeah.
Like very certain people are.
Poor, yeah. Because the next town down in Oak Ridge, they're all up in arms about Popeyes. Another negative connotation attached to that in a nice town. And so I always thought it was interesting because I could pay like twice as much for paper towels at the Lowe's as opposed to Dollar General, which is literally right across the street. And, people up in arms about it. And I'm like, I'll buy my cheap stuff over there. And so I did a study on that. I thought it was kind of interesting on variety stores, in particular Dollar Tree, Dollar General, and what's the other one? Dollar Tree, Dollar General, and Family Dollar. And I think that the green ones, the Family Tree and the Family Dollar, kind of combine forces in some places. And so this is real basic kind of what change detection looks like at its most basic level, meaning in 2019, here are all the kind of discount stores. In 2027, here are all the stores. And then I can make a little map and see, okay, this is where all the new ones were added. And I live over in Greensboro, and so they built one right here. I live over here, but we had a house over here where we lived in, and we rent out, and it's right at this intersection. So they built it like a few miles away, but it's accessible to kind of southern Rockingham County, and there's a street here called Church Street that kind of runs all the way up there. But this is kind of what change detection, where'd they add stuff, where'd they take stuff away, at the most basic, just mapping. Now, how do I want to address this quantitatively? Here's another one here. This is COVID-19 incidents in April of 2021. And what I made here were cluster maps. We've heard the word cluster before. I think I used the word heat maps, where it's kind of higher, where it's lower. What's the definition of what is a cluster? We've heard the word cluster, right? Group of data, group of high values. High values surrounded by other high values. What's the word high mean? What's a high? I hate to ask such kind of fundamental or simple question. What's high mean? High compared to what? The average. Do we know how to compute the average? Of course. Now, we get in some really weird situations where when we work with outliers and we have like a zip code where one person died of cancer and only 4 people lived in the zip code, so 25% of what do you think that's going to do to the average? Move it up, what do you think it's going to do to these clusters? It's going to tweak them really, really, it's going to make it look really, really odd. So we need to be careful about some of these outliers. And in the paper that I posted in the announcements about the cancer research, we kind of went through and vetted all like low population zip codes because we ran into some of the zeros, which are understandable, but some of these, 2 people died of cancer, only 5 people lived there. So you have like a no, you don't, it just happened to be 2 people. They might have been related to each other who lived in that one zip code. And so when you start to do high quality, comprehensive, holistic research, you run into a lot of the challenges in working with actual data. So this is clustering. So these are high values surrounded by other high values, and you can see where the clusters are. If COVID were random, what would this map look like? It'd just be all yellow. Because we'd have high next to low, next to medium, next to another high, next to another low. So you can see these are hot spots with 99, 95, 90% significant. We'll talk about what that means as opposed to cold spots. Cold spots are low COVID rates surrounded by other low COVID rates with 99, 95, 90% significance. Meaning the chances of this thing being a cold spot, being surrounded by other cold ones are really, really, really low due to random chance. And that's what we call inferential statistics. That'll be something we get into after the midterm, where do we look at how does this map compare to a random distribution of COVID rates? It's all inferential means. This is a big fancy word for comparing it to random. So this is the hotspot map of April 2021. Here's a hotspot map of a few months before. And basically, I just kind of did some overlay analysis and figured out, hey, all these red and dark red areas are areas that are increased or are brand new hotspots. These other areas are brand new cold spots. So I could do some type of overlay. And so we can start to look at nominal classifications there where it's a cluster versus non-cluster or categorical. Because these days with data, we talk about numbers, but we can convert those numbers to classes. Like, hey, this is a hotspot, emerging hotspot, and I can color these in appropriately. So you can still kind of figure out what these mean, and we can associate these with things that people understand. Because these days with the ArcGIS Pro, like ArcGIS Pro gives me all these things, like this thing, nice and neat here. And so I can kind of group these. I can deconstruct this. I can convert these to graphics and do other things, or I can change these labels that we start to look at a little bit here. Now, when we look at attributes that should be normalized, the one that I want to talk about is population change. Typically, we talk about non-normalized values being population change by count. Okay. Hey, this county gained 3,000 people. This county gained 14,000 people. They lost 6,000. Is that a lot or a little? I don't know. I bet you Wake County probably gets 100 new people every single day. Every single day, 100 new people move into Wake County. That'd be a lot different if that was Hyde County, which has 4,000 people in the entire county. So what we start to look at is percent population change by county. Now we can do this easily in Excel. Now when we have graduation rates, I can just subtract one column from the next and map that thing. And that's what we're going to do later as part of our case study number 2. And so I can just calculate a brand new column. And so 2012 minus 2000 or whatever, 2012 minus 2008, I can see this is, -4, meaning that it went down. And I can go and map those. And believe it or not, there are maps. Excuse me. And I can map this change. So even graduation change rates are spatial in nature, which I just think is, interesting. Now, there's reasons for these. What do you think some of the reasons are? Access to these areas in blue. What do you notice about all these areas in blue here? These are all ones that went up the most. Yeah, went up the most. Yeah. Well, this is where graduation rates went up the most. They went up from 60 to 70% or something like that. Couple reasons. Well, for the data, they started collecting 5-year graduation rates as opposed to 4-year, but still have these patterns. But you see here, like Durham County or Chapel Hill might not be as high because what's the highest you can go to in high school graduation rates? 100. So if you're 95, you can only go up 5. That's the most you can go up. Where that some of these other counties, if they're at 60, you got 40% that you can go up. So, but I always thought it was neat that there are spatial patterns related to changes that are derived from existing rates. So we can manage it. Now we can do this in Excel. And since we've already done calculations in Excel, we can do equals one column minus another. And it's fairly easy to do. So I've got POP 2000, I've got POP 2004. Those of you who've taken my classes previously, I show this chart a lot. I probably need to update it. And I can just calculate the population change. 100 times new minus old divided by old, multiply the whole thing times 100, and I get population change. Can I get population change over 100%? Is that possible? Yeah, you can. Yeah, you can get population change. Can you get negative population change? Of course, population has gone down. So think about things, what are possible values? Because things like percent Hispanic by county, that can't be more than 100. But population change, if I go from 100 to 300, that is a 200% population change. It means we've doubled or added more, more than 200% more. And so when I look at this, we want to make sure these numbers make sense. Can you really, between 2000 and 2004, have 100% population change? If something has 100% population change, what does it mean? Double. It's double. That's a lot. Those of you taking the World Regional Geography, Intro to Geography, typical like fast growing countries, say like Ethiopia or Nigeria, what is like the population increase for those countries? Isn't it like 3% or something like that? Isn't it something like that? Remember that stuff from McGinn's class? Who took it? Who took his class with McGinn? You haven't taken McGinn's class?
I took urban.
Oh, okay. No McGinn's classes?
I've taken this class, I remember the percentage.
Okay. Really high rates. All right, what were you gonna say, Juan?
As I did took his class.
Okay, all right. What's a high population growth rate? Like 3%. Those are high, those are relatively high. In the United States, it's something like 0.6, where people having people, births minus death, but in this country, we got a lot of immigration that accounts for the high population growth rates here. So you see a 36 right there. You can see that's pretty significant. So I'm going to talk about some of the scenarios and situations where we can measure change, some of the things I've done before, and then we're going to go do it ourselves. We're looking at impact evaluation to reduce commercial burglary. We're looking to prepare a map. I got a couple of maps here. I've got commercial burglaries during, after, not just basically subtracted. That's kind of, we might want to look at that. And instead of labeling like -2 to -17, biggest decrease, biggest increase. So we can change the legend on those as well. And so I can make these things blank, like biggest increase, no change, biggest increase or decrease and increase. with these here. So we can just look at the change because we typically were going to group these by block or zip code, census tract, some unit by which we collected. Now, in a few weeks, we're going to start looking at things that are collected in squares. Nice, neat, pretty squares. There's going to be advantages to those. There's going to be some disadvantages to those. Here's another study that we ran where we're looking at study area within Durham, inside of the area, outside of the area, where I calculated population, median age, percentage of people under the age of 18, median household income. Doesn't this kind of look like the paper that you read, where I just ran, what I do, I ran some summary statistics, and I averaged up a bunch of stuff, and I said, let me get the urban and the food secure, urban and non-food secure, rural and food secure. And I just ran summary statistics, and while I was there, what'd I do? Let me do the average and the mean and the max and all that other stuff and stick it into a nice pretty table for you all to read. So what we have here is Durham crime data. Previously, they used to give me this in a DBF file, which is basically kind of like a glorified CSV file. These days, now we can go to a place called Open Durham and we can download the crime data just like that. So we taught a class last semester called crime analysis, where you go to Open Crime, you pick the year, and you're going to download every single crime in the past year. And then now we can go and make a map on it. It's got the day of the week. It's got northing and easting, which is a little different than latitude and longitude, where this is going to be using the North Carolina State Plane projection. Because typically, what is the projection system called for latitude and longitude? What is that called? What's the projection system for latitude and longitude? It's called the geographic coordinate system, geographic. Okay, geographic, where that northing and easting are going to be measured in feet. Okay, so if we put North Carolina onto a flat surface, it's measured in feet, and we stick some 0 point down in Alabama, so we can go over like 2 million up 400,000. We get X marks the spot, and then we have it as addresses here. So we can make our data look like this here. So this is the NCC campus. We're over here. We're over here. So we can see all these crimes right here. We can see the X and the Y. We can see the day of the week. We can see the address right here if we want to. If someone gives me the X and the Y, I'm not going to go through and map the address, because we map addresses all the time, right? I could just go and type in my address, and we got a little blue point that pops up. I know the X and the Y using the existing coordinate system. And so what we did here, we kind of broke crimes down into part 1 and part 2 crimes. Is anyone familiar with part 1 and part 2 crimes? Part 1 are crimes against people and property. Part 2 crimes aren't as serious, even though things like DUI are classified as part 2 crimes, but I'm sure it's classified as part 1 if it's like vehicular assault or whatever, or negligent homicide or whatever. So that's a little bit more for our criminal justice folks, but drug offenses, simple assault, vandalism, DUI, disorderly conduct, fraud. And so we kind of got these crimes from 25,000 crimes, we broke them down to part 1 and part 2. And then I ran a spatial join. We know what that is, where we counted the number of crimes by zip code, and then we calculated the values. So I'm actually just talking about the stuff that we've already done, where we normalized the number of crimes per 1,000 people. And I went through and calculated these rates for 2007, 8, 9, 10. And then I calculated the average for the total crime rate, the part 1 crime rate. And then I started to see, hey, part 1 crimes for a particular study area account for 53.6% of crimes outside of the study area, but 43.1 within the study area. And then these are the different crimes that I had right here, because the end goal, I forget what this project was for, but they were looking at something called the bullseye. They were kind of, Durham Police Department were focusing on this area just north of Route 147 here. So this bullseye here, and I think I was working with some criminal justice folks, where we are calculating changes in crime rates between 2007 and 2010. And so you can see green, good, red, bad. And so you can see in this bullseye right here, just north of the NCCU campus, it largely went down except for this one. Now, basically what happened here? Did the bullseye really work? What are some things that you might say? Did the bullseye work? I think so. I think in some cases. But what about over here during this time period? I think to me, the crime has kind of moved from here over here. I was like thinking kind of, so that neighborhood kind of off back behind the tobacco trail right there, kind of just moved right there because the yellow stays the same. And so the green increases, the red, the green decreased, which is good. So they got rid of all the crime kind of downtown near DPAC and everything. The bushes all kind of moved somewhere else. So did the job. So in the little newspaper right there, bullseye credited for 10-year crime low. Oh, nice job. Crime went down in the bullseye. But it's right. It's right. So I thought that was interesting. Now some other things with respect to change detection analysis, because we're just looking at how do we measure change? These are some kind of interesting techniques, and these are evolving techniques as well. One of them, the city of Winston-Salem and Greensboro, and I'm sure Durham does it from time to time, they go and annex areas. They basically just say, hey, you're now part of the city of Greensboro. And over in Greensboro, they actually kind of gobbled up this area near the airport, kind of a little bit nicer area. Over in Winston-Salem between 2006, 2007, right before I started working over at Winston-Salem State, they went and just gobbled up a whole bunch of areas and say, instead of being part of just Forsyth County, you are now part of the city. And it's kind of interesting. I live in a town called Summerfield where they're actually, what am I going to say? De-annexing like 1,000 acres, I think it's a fifth of it, like 10% of the whole Summerfield. Why would they de-annex an area?
One is because the city that owns, then the other is because the people that live in it, with the fire and some of the services don't want.
Yeah, well, over where I live, in Summerfield, they had this proposal because you have to live on like 0.75 acres to build a home. So we had this big developer buy up this area of like 1,000 acres called Summerfield Farms, where he wanted to put high density housing there. All these kind of greenways, and he promised for, Section 9 housing and all this other stuff. But you build a low income house, what's it really it's not going to be a low income housing. It's going to be the highest bidder. You know what I mean? So it's not really low income house because, oh, here's $150,000 home. I'll pay 175 for it, and the person who wanted to buy it for 150 or could only afford 150s, they're going to be out of luck. I'll come and just buy it for a little more. So I had all these promises to do that, but I went to the city council where city council said, no, we're not going to approve high density housing. So the guy said, well, I'm buddies with a North Carolina state senator, so I'm going to go and have this area de-annexed. So you're not, you all people aren't going to vote for it, and I'll just appeal to Guilford County and have it part of city of Greensboro. And that recently just passed. Okay. So I thought that was kind of interesting. Now there's two schools of thought, I'm just kind of like, don't let the door hit you or the good Lord split you, you figure all that stuff out. You figure out how to get water and, figure out water and sewer and services all up there where you have to drive through our town to get through now this town here. Where the other school of thought is, okay, usually there's going to be someone come in with bigger wallets than you and you just deal with it, deal with it, money speaks, money talks, unfortunately. So, but I don't want to go too far off on that. So you'll hear about that a little bit. It's the largest de-annexation ever in the state of North Carolina, history of the state of North Carolina, because a lot of times we're gobbling up these areas, not, getting rid of them. not getting rid of them. And so why do they gobble up these areas? Taxes, tax base, this area right here probably isn't, they probably don't want these folks, they want these folks. And they don't want these. And there might be special cases or whatever, they might be special cases right here. And so when you annex areas, you're basically paying taxes to the, city instead of the county, and your tax rate is gonna probably go up 50%, at least, definitely. I live in the city and my taxes were a lot higher than they are in the country. So when we map crime, we get crime using addresses right there, and we can do this called geocoding, and I can map the part 1 and part 2. And so when I make a crime map, I've got something like this. Now, the challenge is that I've got crime data from the city for only the year before, for 2005 and then 2007. Now it includes the whole city. So how do I reconcile working with data that wasn't there in 2005 that's now there in 2007? It's tough. I had to kind of be clever and think about this. Because, what are some of the challenges? Because a lot of times when you call 911, you get pulled over by the police or whatever, who shows up? Does it just say police? Well, you've got NCCU police, you've got Duke police, you've got City of Durham police, you've got Durham County police. And believe it or not, when you go to the Open Durham website and you type in crime, it's got Durham County, Durham Sheriff's Department, and then you got City of Durham, and their GIS systems and the way they collect GIS data related to crime are entirely different. We got Josh in the back, and I bet the systems are different for the city and for the county, right? Yep, entirely different. Okay.
They're still there.
Yeah, and it's kind of like, I think Charlotte, Mecklenburg County has done a real good job of integrating their services and really marketing, promoting that they're kind of their city county, their city county, as opposed to some of the challenges that we have here. So even when I get the Forsyth County data, they collect it using different systems, different terminology, different methods, and I can't put them together. So I can go and make a nice pretty map like this, and then I can change crime from 2002 to 2005. Oh, great. Now, but I started getting crime for these areas here that didn't exist from 2002 to 2005. And so I kind of figured out what are some things that we can do. And this is kind of leading into what we're doing next week. We're looking at point pattern analysis and polygon analysis to look at some of these patterns. Because when we look at the map for 2005 to 2007, look at it, like we got these new areas here that didn't exist in 2005. They did exist, but they were in Forsyth County, for which we don't have crime data. So you can see I made a couple of just nice maps right here. But what I started to do is look at some point pattern analysis, and these are descriptive metrics, and one's called the spatial mean. So how do you calculate the mean of something? Add up all the numbers and divide by the total number. I got a whole bunch of crimes. Add up all the latitudes and divide by the total numbers, and you got one latitude. Add up all the longitudes and average up all the longitudes, you got another number. And so now we have a descriptive metric to describe spatial data. And then we have things like spatial median. Spatial medians there's a couple different definitions of spatial median, center of minimum distance. But what I did here was, here are the people, the population. We're going to talk about population centroids, where when I annexed the area, the center of population moved a little further to the north. We gobbled up more people, or they gobbled up more people a little further to the north than to the south. But when I looked at crime, all the centrality metrics related to crime means we gobbled up more crime to the south as opposed to the north. So we gobbled up more people in the north, but more crime in the south. So these brand new areas. So where should we be allocating resources? Probably a little bit more in the south. And so these are spatial means, spatial medians, mean population centers, center of mass. You might have heard this term in physics if you've taken physics before. So I thought these were kind of neat here. These are for part 2 crimes, the same exact patterns. Some other work that we've done with QA/QC. One of the things we look at is a lot of the work that we work with is on InfoUSA, Data Axle, where they give us all of the business data. So there's this big business database of all the businesses, home businesses, everything. Is it correct? Not necessarily, and it's hard, even like, Google Earth or Google Maps, you look at something and like, hey, this thing really isn't open or it's misattributed. There's no centralized location for these. So we've done a little work, and this grant is just finishing up. Little work has been performed on technologies, field check these data to see how it'll be impacted by errors of omission and commission. Now, what's the word omission mean? Not there, okay? Hey, there is a supermarket here, but it's not on my maps. And then commission meaning, hey, it says there's something here, but it's been closed for a while. And it's typically not a mistake, it just hasn't been updated. So that you might see these areas in green right here. These are all supermarkets in my study area. And so these people over here live really close to a supermarket according to my map, but what happens if they didn't? What would happen to the foodscape and food environment if that were the case? Hey, these people have to drive all the way over here. And so we did a project where I helped create, I did it. Trying to tell myself I know what I'm doing. But we created a phone app where we loaded all of the existing data from supermarkets into this kind of 5-county region here between Durham and Greensboro. My parents live like right down here, and it says there's a supermarket there, and there is no supermarket there. It's like a glorified, basically glorified gas station. So it said these are all the supermarkets right here. And so I loaded these up, and I had our students go and visit those, and they basically went there and took a little picture of it and said, hey, this isn't a supermarket, it's closed. Yeah, it is a supermarket, it really is. And so what we did was we did some before and some after. Now, there's a lot of things we need to do because I went and, as you can imagine, if I were to look at all the businesses here, a lot more businesses than this. And so what do we look at? We look at these things called NAICS codes, North American Industry Classification Standards. So you can clear out things like, vape shops, fast food, everything. Now, fast food is even tougher because you got things like Subway, which are generally good, versus other fast food like McDonald's and Burger King, which are typically, I don't even want to use the word bad, but there are good healthy options there. I remember I went to McDonald's recently and I was like, I want a salad. And they're like, we don't even do salads anymore. Just like, who are you kidding? Just get the chicken nuggets, feed your kids, and get out of here. You know what I mean? Like Wendy's still tries. They got the salads and stuff like that. I mean, but fast food. Now, who's going to go through and pick out Subway versus Panera Bread versus these other things? Not me. I'm just kidding. But let someone else do that. And so a lot of times these are generalized here. So I cleared out this classification code because you got to figure out what these are. And so when you do this analysis, most of the work that you do is like data preparation, so you can actually get something that looks like this. It probably took me half a day to get a map that just looks like this of all the supermarkets sitting in my InfoUSA database provided by the government every year or so that has all the businesses. Because it gives me it for the entire US. And then it took me another half day to create the little app, load it into something called ArcGIS Collector. I think it was ArcGIS Collector, so that my students can click on it and go to it. And they can type in information related to it. So I had to set up all the edit privileges so they can go and edit it. I had a couple little drop downs and things like that. There's probably some better ways to do it. And so I can run some statistics on these, just like you saw last paper, where the total population is about 458,000. We've got 90 census tracts here, 267 block groups. these block groups are just subdivisions of census tracts, and we've got blocks, which are subdivisions of blocks, but within blocks, I just look at population because I can't collect information like age, race, income, education, attainment, all those other things within blocks, because you've got, some of these have 0 up to maybe 50 people, and so you don't want people getting hold of block level data because they might calculate, 80% of the people don't have a high school education. Well, it's just 4 out of 5 people, and you don't want people kind of taking off with some of those data there. Now, we ran the QA/QC. This was a student named Quentin Butler, and then Isabel. I don't think anyone remembers Isabel. Oh, you remember Isabel. She's working on her PhD over at NC State in the geospatial analytics. But you can see here, so I've got the grocery stores before QA/QC and the grocery stores after QA/QC. And so you can see here, these red dots right here are all supermarkets that really, those are areas of commission. Meaning these aren't really supermarkets right here. And then I did find an error of omission, right, in Pittsburgh, meaning it wasn't in the GIS database provided, but it was there. But it was relatively close to the other things right there. And so what I wanted to do was, I created a 10-minute drive time, because most of the time, if I create a circular buffer around things, it's easy to calculate cartographically, but in reality, you type in your directions to go somewhere, what do you care about? How long it takes you to get there? Even though it might take more miles or whatever, that's what I care about. And so what I did was I created a 10-minute drive time around the old map, created 10-minute drive time around the new map, and I started to say, who are the people or how many people were impacted by this change? Because these people who live down here, my parents live down here, they are maps, and you go to the USDA Food Access Atlas, they say my parents have access to healthy food. They don't. And they're going to drive down here to Siler City or up to Burlington or whatever. If they really want to go to the supermarket, or they really want to go to the gas station, pay, $1, $1 for a banana instead of 50 cents a pound up at Food Lion or Lowe's or wherever else, they're going to have to take it a little bit of a drive. And then this is a 10-minute drive time with these. And so what I did was before QA/QC, after QA/QC. There was 104 grocery stores before, but 20 less grocery stores after. And so you can see this gigantic overestimation of people, and you can look at this with the block groups and the population, but this overestimation of people who have access to healthy food that, it's about not quite 10%, about just under 10% overestimation of people who are food available, who really aren't, which I thought was kind of interesting. And then we look at the population within 5 miles, and then like I care about, the population of people within 10-minute drive time of this, where after QA/QC, it's 401,000, when our data said it was almost 428,000. And this is just some simple little project where we went through and, created some phone apps. So we created some technology right here. So, and anyone in this class with a little bit of work can go do the same exact thing. We have apps, Survey 123, Collector, we have things, what's the new one? Quick Capture, have you heard of that? Quick Capture, that we can go and collect GIS data. You can make your own GIS data. And in this case, I created my own map project and then just loaded it into here. I set the edit privileges so that anyone can edit it. You better not delete stuff. And then we went through and did that. These are some of the errors that we had, like businesses in a grocery store. The point is actually a residential location. So like the owner's home is there. The food source was closed. So this is what we call temporal accuracy, attribute accuracy. Horizontal accuracy, meaning, maybe they typed in or someone typed in the wrong address, or it's really located far away, or point was found in the field that didn't exist. So these are just some other examples. These are just some other examples of These are just some other examples of doing some change detection analysis. The last thing here before we'll take a break and then we'll open up case study 2 is this is one thing I'm getting into. I'm still in love with it. I talk about it a lot. It's called the Jacquard Index, meaning it measures, it's basically a measure of similarity from 0 to 100 because these are different maps here. So we talk about the word rural. What's the word rural mean? What is rural? I know what it means. You know, what's it mean? But not having access to basic amenities. They much use the word in the boonies.
Like US census is like less than like 5,000 people per given.
Yes, now, okay. So boonies, how do we quantitatively express those? There's a lot of different ways we can quantitatively express those. And believe it or not, there's 9 different like quantitative definitions of the word rural. You know, it's kind of interesting. And so I've got one here, and this is the definition. This is the definition from the Census Bureau where it's based on population density. So these areas in red here, these are zip codes that are rural zip codes based on population density. These here are based on MSAs, metropolitan statistical areas, which are county level designations that say this county is metropolitan, micropolitan, or rural. Metropolitan, big city; micropolitan, middle-sized city like Wilmington or Greenville, and then everything else is rural. So these are all the zip codes in your quote-unquote rural counties. And then this is called RUCAs. These are rural urban commuting patterns where that has classes from like 1 to 10 based on where people drive to work. And so these are all the rural areas where, I forget not the definition, but these are all the rural areas where people live in rural areas and they commute to rural areas. So which one of these is the best? This is tough. Which one of these is the best? Depends what you, yeah, depends. And there's like 5 other definitions that we could use, but these are the ones that I was able to quantitatively create because we wrote a paper on this. Chimo, you were part of this right when he got here. He did a lot of good QA/QC and so a lot of good writing on this. Which one's the best? And so imagine all these zip codes having a attribute table and a field for census definition, MSA definition, and RUCA definition, where it's yes, no, or yes, 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 no, no, yes, no, 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 yes, yes, yes. And we ran something called the Jacquard Index, which basically figures out or calculates the intersection versus the union. And so there's 763 of these right here, or 763 zip codes. And so it compares how many of these reds are similar in each map, and it does it pairwise. And pairwise basically means it does this versus this versus this, and then this kind of like round robin, if you can kind of think of that. And so we compared these. And so when I ran method 1 versus method 2, 65% of these compared, matched up. So for these, this one versus this one, 65.3% of the reds lined up, and then the whites lined up because them both being rural is also a match, or them both being urban is a match. Okay, so they're either urban or rural. There are some weird things with the card index where we work with no data, but I didn't want to bring that stuff in. Yeah, I didn't want to bring that stuff in because that union is going to change for each of these. Daniel's thinking, he's like, man, this stuff's pretty. Really, we call some of these binary sets versus groups, and we can do some neat things with lane code. So 65% of these kind of lined up. And then when I did the next method 1 versus 3, 74% of them lined up. And then basically what I did was for each method, I added them up and the winner was the highest one. Meaning that method theory agreed with the other two better than the agreements between this. So this was the quote unquote best, meaning it just had about 3/4 of the agreement, or whatever, 71% of the agreement with the other two. That was another way here. This type of, change detection before, after, or whatever. This is relatively easy to do. The one thing I'm trying to do in in my grants is I'm trying to get a tool that does this. I created a little tool that does this. And I think if you take data science class, you're going to see this tool. You're going to see this tool. Now we're going to have this data sitting there, and then you're going to see the code that I created. It's really pretty simple, relatively simple. It just says, instead of me doing calculations in table, instead of me doing like queries, like, let me see where column 1 equals column 2, I just run a little tool that's displays it. It says, hey, when you do column this versus column this is how many percentage of them are correct. Like I was telling the group I met for before class, where that people are going to like to see that a lot more than you hand jamming and calculating these, where, hey, I created a little tool that calculates this Jakarta. And I'm trying to convince people at different organizations that they really like this tool and they really want it and they should give me millions of dollars for it, but they haven't been convinced of it yet, because I think they just think, hey, why don't you just write a little Python code that does it, or you can just hand calculate these. But I haven't given up on it yet. I think the next time I get a no, I'm probably going to have to give up on it, but that's okay. I've been told no a lot, so nothing wrong with that. So, see, when we get back, what we're going to do is we're going to open up case study number 2. We're going to map the change in COVID rates. So we're going to add a new column and calculate these. We've already done this in Excel. So we're going to add a new column, calculate the change between 2 columns, and then we'll start looking at exercise number 3. So I kind of want to get out of here a little early just because I got to hit the road. I'm going to be in the air by 6:30, so I want to maybe get out of here by 9 or whatever. All right, so we'll take. Let's be back here at 6:05, and then let's make sure we have case study number 2, and this is what case study number 2 looks like. So it's called position paper, but all you need to do is it's the position paper right here. So if we go to like classwork, case study number 2, it's called position, but it's also downloadable from modules, but it's called position, okay? Because this is the data for the position paper. So I do want to explain some of the data that are sitting here. So I'll let us kind of do that and take about 10 minutes. Yes. Okay, all right, thanks. I'll get those up there. Maybe.
Yeah.
There at 5, it's open.
Yeah, just
So do what you did.
the same.
Okay.
So,
You applied for this internship?
yeah.
No.
Your application will look like student distance, I'm not going to normal. More than two, like if you see, you know, this works. Like if you apply more than two, the system is. Yeah. Yeah, but another sense like those. But I, yeah, also. That was just for a say what. They are all the same. They are all the same. So you can apply the treatment. Then what's coming? Like, which we don't want and they have a lot of dedicate to this. But I need to go out here. Just like again. Yeah. Okay. Wait. Sorry, where's the then they change the line on time. To one day, easily gets shut off. I think it's still something. Where's that? It's shut off. It's so. I think we shut off is. We not going. So if you want to have the village. That's the mistakes.
Realize when you see it helps.
Yeah, I'm here. Now I can do this. I've done it for 2 years.
That's you want.
With my response to this.
Oh, you taking the money? Oh, okay.
It's more like this.
Yes.
Yeah, right. But without, yeah, it's right.
It's great pay.
It's straight. It's like,
So, yeah, I have.
yeah.
I started out outside of here. Or you take out, might have to take it, right? It's like,
Yeah. So I exactly what I'm saying. The drivers here. Uniquely. That's not right. That's going to be more. This system design. But what I took, why I just, but it's just orders, like, like, any of them, like, you can take any of that, like, field, some of them, but even if it's confident. Right, so, yeah, I know, what else, just take it, like, the thing. Exactly, yes, so you can be necessary, so we can take the AI class.
Yeah.
It's the review, so, saying that should be.
Is there any survey you want to
See, you already did the air class.
Yeah, I mean, my words is being like just me. At the hell of mathematics. That would be. Yeah. Yeah. That's the seminars. Yeah. You don't anything, you just sit down.
Hey, Lamana.
How you doing?
Good. How's everything going with 4010? You got it figured out?
I feel like I still need help on spatial drawings and
Okay.
tabular drawings. I tried to email you. I don't know if you've seen it. I think we should
Yeah.
meet because I think I have the right idea, but sometimes
Okay.
when I be putting in stuff, it don't come out the way that it should, and I get
Okay. Yeah, we're probably just missing something. I don't know if you heard at the beginning of class, I'm heading out of town first thing in the morning.
yeah.
So,
I
let's
seen
get-
the
oh, you saw it in the other class. Yeah, that's right.
Yeah.
Okay. So let's get
what-
that. Let's try to get that sooner than later when I get back.
Okay, well you just let me know when you're free, and then I meet whenever you're free. I don't have
Okay,
nothing.
all right. All right, that works for me. Just yell at me by Tuesday if you don't hear from me. I'm still playing catch up.
Okay, well I help you get everything together with your family.
Yeah, well, it'll be fine. It'll be a good opportunity. She was older, but it'll be a good opportunity to go back to the homeland there. So,
Yeah. Well, I'm sorry for your loss.
all right,
Yeah.
thanks.
All
All
right,
right, all right, we'll get started in a minute.
Okay.
One of the people who are academy with us is actually assistant chief or something.
Okay.
She's been there since we graduated from fire department in 2004. So
Oh, wow.
she's been there.
Okay, what's her name?
Jennifer, actually, her married name is not, how is Jennifer's married name?
Okay.
She, can't remember it.
It's not Janelle, is it?
No.
Jenna, okay.
We always probably didn't go through that.
I just think this is kind of, funny isn't the right word, but it's just, there's a lot of blame to go around. To me, I'm kind of just, and the mayor lady lives around the corner from me, so, and the other lady who was running for mayor lives across the street from me.
Especially the same neighborhood.
Yeah. Like, there's some real like high rent stuff there, and I'm not, like, we don't live in the high rent, like, I couldn't afford to live there.
Trust me, once, yeah, I understand that. So I still live in my original apartment in Greensboro, which is on across Sedgefield, but it's on the south side.
Okay.
Jamestown, we cover Jamestown.
Yeah, my brother lived down in Adams Farm.
Yeah, we cover.
Yeah, he lived right off Adams Farm,
Okay.
right, or Adams Farm Road. Yeah, 'cause
Yeah.
his wife, he passed, but his wife taught at Pilot.
Okay. Yeah, I'm very familiar. That's my original fire district before I came there, and now I'm back there.
Oh.
School and everything else.
Oh, you live in Greensboro?
I just work in not work, but volunteer at the fire department.
Okay, over in Greensboro there, down in Sedge Gardens?
Yes, Sedgefield, the Pine Cross Sedgefield.
Okay,
So we run everywhere from, like I said, the south side. Almost a split from the, what is that, east side of Greensboro all the way to,
okay. Yeah, I kind of like it down there. Like, I like Adams because it's got like the trails and all that stuff there.
nice stuff.
Yeah, they got some nice stuff there, but because I had an apartment right near Guilford College. I moved here and I lived off of Guilford College Road, just right on the other side of 40 from there. They built some new road called the Bridford Parkway, that Bridford or something that goes,
I just saw it last week. It's grown tremendous.
yeah.
Hate to say it, but 20 years.
Yeah, I moved there in 2007. So I bought a place. I was lucky enough to sell my house in Virginia and buy a place
In 2000, oh,
in 2007, right before the bubble crashed.
yes.
But I just sold that place like a year and a half ago because my wife wanted to stay home with the kids. So I was like, all right, I'll sell it. So we got
It should come.
because I rented it out after her and I got married in 2013 and we moved up. She was from Summerfield. She lived in Summerfield. So she moved like 5 houses down
From where she grew up.
from where yeah, she's from Indiana, but she moved 5 houses down from where her and her previous husband lived. And
Gotcha.
we just combined our courts and,
Makes sense.
but I couldn't afford to live, couldn't afford to live there. So do you still rent your apartment out there?
Nope, I've gotten rid of everything.
Oh.
I just travel down there once a week or once every couple of weeks.
Oh, good deal, yeah. I get, because we rent out a house now and then we rent out our basement too, because we got like this, like super basement, like super house, and it's only like 4 of us, because all the kids moved out, all the older kids moved out, like go to college, one got married, and the one girl, moved with the boyfriend, like, okay, we'll rent out the basement, and
You tell you?
yeah, rent out the basement, we got another house right at Church Street,
Okay.
Church and 150, that Lowe's right there, which is new. So we have we bought a farmhouse. Like I was driving to work before the Beltway, I was driving to work and there was just like this dilapidated farmhouse. And I'm like, I'm gonna go check it out. And there was like a written sign on the door. It was like, call this number if you're interested. So we didn't have we didn't have like lawyers. So I was just like, we're gonna offer you this much. And it's 4 acres, and it was a lady whose parents lived there who had died, and she's now in her like 70s. She grew up there, and was just like, "You want this?" And like, this is a offer to you for 110, and she's like, "Okay." We had to put in like 40 grand, like to get like it was previously rented for 700 a month, so like $700 a month people lived there, and it
Right,
was
so it's
just
destroyed.
it was destroyed. So we like, we redid the hardwood floors, original like it took up 3 layers of rug and it was, but now we rent it out for like 1,500 a month and yeah, 4 acres. So we split it. So if people really want it, hey, we got a 2-acre plot, 2-acre plot, and it's a flag lot. So, but I'm not getting rid of that because just in case something happened, because we lived there during the pandemic, it's just me and our 2 kids, because my stepdaughter lived with her dad and then decided not to live with her dad, and the farmhouse was a little crowded. And so we had renters moving out, so like, we rented out our big house, we kind of just like, let's move back to the big house and switch again. So, yeah, I used to bounce checks with my first wife, so don't. My first wife, she could spend any like, she was rough.
It was like,
Like, you used to get these little, I'm gonna start here. You used to get these little things and they thought they were check, like, but like, I'm not getting a check. And it was just like, you have exceeded your withdrawal limit, you've been charged, and they would come like the middle of the month because, all of my bills would be due at the beginning of the month and she'd go like, take it to go do whatever. I don't even know what she did. So, but you get these and like, cool, I got a check. And you're like, no, I don't have a check. Because it looks like the little perforated like notices. It looked like a check. It's like, ugh. So yeah, I got out of that. All right. All kidding aside here. All right. This was the thing, if you check it out, this is kind of neat. This is the NC House bill to de-annex the area that we where I live in there. So it'd be like the largest de-annexation. It's part of like this Villages of Summerfield, and I thought it was neat. So if you ever see this on the news, this is what's going on. And I'm not really sure where to stand on it because I'm sure the town could use all the tax base, but all of the, whole town, like all the staff quit. And so like the planner quit, planner had some GIS, and then all the staff quit because they were all mad about it, and everyone's mad at the managers, but I don't know how you could have made people happy, because at first they're like, no, we're not gonna give it, we're gonna keep the town rural, and this guy had other plans, like, well, I got no money, I'm just gonna go hit up my buddy, hit up my buddy in the state house, and before you know it, this is what happens, so, all right, so what we're gonna do, let's open up exercise, it's called in-class exercise 2, but you'll download it from modules. So I just want to make sure anyone following along is here. So under modules, we're in week 4. So it's called case study number 2 to be worked on during class. So you can see the topics that we covered this week. You can see the presentation, the actual PowerPoint presentation. You can see the video that I've pre-recorded in support of this, in addition to the presentation that I'll be posting in the next couple of days. And then I got exercise 3 that we can start to look at here if we've got time. Then I got reading number 2, which is due in 2 weeks. And then I got the Esri assignment, which will be due next week. So we got a couple things next week, because in 2 weeks from today, I'm going to be at the North Carolina ARC Users Conference down in Wilmington, so I will not be here. ARC Users Conference is a conference for GIS users in the state of North Carolina. I really like this conference because these are people who do GIS in the state of North Carolina. It's a little bit smaller because in March, we have something called the North Carolina GIS Conference, which is like everyone, like practitioners, planners, interns, everyone. It's probably one of the largest state level GIS conferences in the entire United States. And I always try to push students. Last time we went there, it's every other year. We had about 8 or 9 students go. I want everyone going. I put you up in a hotel at the Marriott there, and as long as you go, show up, go have a good time and everything like that, and go kind of meet face to face with people who are going to be hiring you. Have you been to that one, Josh, before, or that's too far? Not too far, but just, you're out of the GIS game,
Today with the from Esri.
Okay.
And they said that they mapped, of course, on GIS day, and they said there was nothing on the map. I don't know.
Yeah. Yeah, sometimes I do GIS days, sometimes I don't. And basically last year I was gone, I was in San Jose for GIS day, and I'm like, when do you all figure it out? I was at a workshop in San Jose, and I'm like, someone else figure it out, and I'm like, they didn't. So, but we have something called GIS day where we have speakers come and talk and whatever else. But GIS, that's where people who do GIS. So you're going to meet like former students of ours. The guy who made that poster right there, he does GIS for the city of Durham. A guy named Stedrick who works downtown. A lot of our students, former students, people who like NCCU go to this conference, and there's neat academic conferences out there, but how many people are going to be in that? Not that many. You're going to be out working in the field, doing this stuff for a living. So those are some things that I try to push. But so I got Esri assignment, case study number 2. So this is what we're going to do. And then I got a video on how to do change detection and create new fields, because we're going to go and create new fields in support of this. Now, this is part of the position paper. So this position paper right here, this is zip code level data that I've collected for the entire state. You can obviously see here, I've got COVID rates here. I've got major cities here. I've got NC counties here. So a nice little template, a pretty looking template map. It's not a layout, so you can't put a scale bar north there on all this thing until you add a layout that we've done before. And I've mapped COVID rates. And so if we right mouse click and do open attribute table, you can see everything that I've started collecting at this scale here. I got, I don't have too many here. But you can see that I've kind of unchecked a lot of the, fields, because this thing has about 100 fields, because I've got like Republican, Democrat, that research that I've done with the voting patterns kind of ties into, utilizes this data set. So I've got here something called ACS, total population. Does anyone know what ACS stands for? You might hear from this from time to time. I thought I heard someone use it. Stands for American Community Survey. Because when do we take the census? When do we count up all the people in the US? Every 10 years, right? 2010, 2020, 2030. A lot of things can happen between 2010 and 2020. So as part of this program right here, this is called ACS. So these are the number of people who live in these zip codes. And there's about 763 of these zip codes. So if I were to right mouse click and click on statistics, what should this number add up to for all the populations and all the zip codes? What should it add up to? Total population, okay? What is that, 9 million, 10 million, something like that? 12 million? Okay, statistics. Okay, good, thank you. Okay, yeah, we got here like 9.9 million here. This might have been a year or two ago here, but we got 9.9 million, just under 10 million people here in North Carolina. And those are some of the things that I just personally like to do to kind of just check myself here. Now, what else we have? We have COVID rates of 01, 24, 2021, COVID rates 3, 17, 2021, 4, 5. I tried to collect these kind of on a monthly basis. Then I caught a couple other things here like distance to the nearest supermarket. There's a lot of different ways that we can measure that. I won't bore everyone with these things here. But I have things like median household income. This is metropolitan, micropolitan, rural. I kind of alluded to this before with the MSA designation. Is something metropolitan, micropolitan, and rural, and then that we can apply it rural or metropolitan, micropolitan, rural. These are things like percent minority, population density, people who live below the poverty line, people who live below twice the poverty line. So if the poverty line is, $40,000, this is the percentage of people who live below $40,000. What's poverty rate depend upon? Income, how many people live in your house and where you live. So if you got 5 people live in your house in this particular location, this is poverty line. Because you can imagine like areas like Hawaii or Alaska where cost of living is so high, poverty level is going to be a little bit higher. Some other neat things here, like the registered Democrats, registered unaffiliated. I don't know what this stuff here is, to be honest with you. I'm not sure why those numbers are there. I don't know. COVID change, COVID rates, all these other things. Is it a USDA food desert? The spending on fruits and vegetables. Now we're going to look at a couple of these things. Now what we're going to do here is, hey, let's just calculate the COVID change rates between 9/30/2020 and 9/30/2022. What's so significant? What happened right at the end of October of 2020? What happened? What's significant? What happened at the end of October? Right, a few days after Halloween 2020. What's going to happen a few days after Halloween this year? What's that? Election. Okay. So this is kind of some of the stuff we did before, where that, hey, let's look at the change in COVID rates between the month before the election and the election. Because I already did this, so I already kind of know the answer. Okay. And so we're going to calculate the change. Now these are rates, okay, and this also means that these build upon each other, so you can't ever have a rate that goes down. So this is the number of like COVID, what are they called? Not deaths, but cases, COVID cases per 1,000 people, and they build upon each other. So people can have it twice. So in theory, you can have like 3,000 COVID cases for every 1,000 people if someone gets it 4 or 5 times or whatever. And so what we're going to do here is we're just going to calculate the change between these. These are rates. So we don't need to do one minus the other divided by the other, because this 281 is on the same scale as this 313, is on the same scale as this 116. Okay, but I want to calculate the change. So this one went up 19, this one went up almost 100, this went up 50, this went up 63. who wants to go and do this for all these? We're gonna go and calculate new columns that go and do this, and then we're gonna just make a nice pretty map out of this. And we can maybe not call it numbers here, but we can actually go and designate these as, you know, lowest increase, highest increase, or no change to biggest change, because they might just stay the same or whatever. And so what we're gonna do here, we're gonna look at this hamburger over here. Now, these things are called hamburgers because they kind of look like hamburgers. So we're gonna look at this hamburger symbol over here, and this hamburger gives us options that we can do on our table. Okay, what I want to do is I'm gonna click on Fields View. Fields View. So I'm gonna click on Fields View right here. And if you look at all the fields here, you can look at all of the fields that I've unchecked because I don't want to show it all to you. You know what I mean? Because you'd get overwhelmed really quickly. So we're just going to look at the change between 9/30/2020 and 10/31/2020 as well. So all the way down at the bottom, we're going to add a brand new field. Okay, so we're going to add a brand new field. What do you want to call the field? It's going to be mapping change in COVID rate. So what do you want to call it? COVID change. So we're going to call it COVID change. Okay, we can give it an alias so that it reads a little prettier. And so if I really wanted to right here, I could maybe call it, you know, COVID change. Now, the $1 million question here, we have something called data type, and I haven't gone through these too much, but if I were to click on this column, this drop down here, I got a bunch of different data types. I've got short, long, float, double, date, text, blob, WID, raster. Okay, short and long, those are integers. And if you look at the data, the only data I have are integers. They're rounded up, basically. So we could store it as a short or a long. If we have numbers that require decimal points, what do we want? We want float or double. Floats are just numbers with decimal points. Doubles are really big numbers with decimal points, like -17 trillion.45. You know what I mean? Because basically, when you store a number and we allocate these, we're just telling the computer how many ones and zeros to set aside so that we can store it. You know, it's like your flash, kind of like your flash drive. I'm just going to store it as a short this time. And then up in the top, I'm going to click Save. I think we've already done this, right? Okay, so we're going to click Save right there. Now this is where it gets a little tricky here. Now all the way to the right, I have a brand new column called COVID change. And I'm going to right mouse click and click on Calculate Field. And all I'm going to do is kind of go through and what am I going to look for? All right, I'm going to do the COVID rate for 10/31. So my COVID change is going to be, I'm going to double click COVID rate 10/31/2020 minus COVID rate 9/30/2020. That's all I'm going to do here. Was I smart enough to go and like type in these exclamation points? I'm not that smart. Okay. Why are these exclamation points there? Because it tells it that it's a field. So in whatever language, Python 3, it knows, hey, when I see these exclamation points, I'm referring to a field in my table. So these are really simple to do. Really simple. So I'm just going to do new minus old. Do I need to normalize by anything? No, they're already rates. They're already rates. Should I have negative numbers? No, because I told everyone they build upon each other. Can you have zeros? Yeah. If it was 200, it stayed at 200, it'd still be 0. So just think about what good values might mean. You might yell at you about some null values. We're going to ignore those. So I'm going to click OK. I got a little warning. It says certain rows set to null due to error while evaluating Python. unsupported data site. What's the word null mean? Nothing, nothing. So if it's null, can I just put a 0 in there? No, it means we don't know it, it wasn't collected, or it wasn't collected in time, or whatever. If I add anything to null, if I add like 37 plus null, what does it equal to? Null, exactly, okay? And so whenever we have these nulls in there, you need to be really careful about those, because a lot of times people put zeros in there, and it's not a zero, it's nothing, we don't know what it is. And so that's gonna tweak, move your average up and down if need be. Which we don't want to do. All right, so now what do we have here? We have COVID change. We have this one went from 300 all the way down. We got a bunch of nulls here. Okay. Who wants to make a map out of this? To me, you think this is going to be spatially related? You bet. So I'm going to right mouse click on symbology. Now my field, instead of COVID rate 11/19/2022, what are we going to do? COVID change. Boom. Look at that. So this shows what happened in the month preceding the 2020 general election, where COVID rates increased the most, where they increased the least. Spatially related. I think it's really, to me, I think this is interesting. Where did it increase the most? Kind of northwest of Charlotte, and then kind of up your 95 corridor. Now, the one thing that Dr. McGinn and I did with our research is these areas in green, especially on the 95 corridor, these areas where they had the highest increase in COVID actually had the lowest by mail rates. These were the folks that still showed up at the polls in the middle, still in the middle of a pandemic, to vote. Now, what are the reasons for that? Could be a lot of reasons. They might not have had the resources to vote by mail. These are relatively rural. So, education, just the actual resources themselves, might have led to this. But these are all spatially related. I think this is interesting. What we're going to do later is we're going to run cluster analysis on these, because at the end of the day, who makes these divisions right here? Me. You all do. And what I was talking about with some of the other folks is that I'm a big quantile person. I love making quantile maps. Love quantile maps because each color appears the same number of times. And I even like this color scheme because we take advantage of both the yellows and the greens and getting into the blues instead of going just light red to dark red. So we can take advantage of a little bit more of the spectrum. So maybe if we have like a yellow to green to blue, you might get 8 or 9 classes as opposed to something like a red or an orange, which doesn't have a lot of internal contrast, where you're going to max out at about 5 classes. Now, what are some of the challenges of making quantile maps? Why might making this map be somewhat misleading? And you 4 don't answer. I want someone else to answer. Okay. Why might, if I go and make this map with this legend, why might this be misleading? Right, and this is quantile, so each color appears the same number of times. I just lined them up. So the first, I gotta do math in my head, but the first 120, the next 120, the next 120, the next 120, and the next 120 are all just different colors. What's the word range mean? What's that? Max minus min. What do you notice about the range in the middle here? 14, what's the range over here? Almost 300, what's the range here? Twice that of the middle. Okay, so really, it looks a little kind of wacky here, because our ranges, if I right mouse click and click on statistics, and this is where we can start to get into some like exploratory data analysis. This is the population change. This is the population change. My wife needs the Netflix password, so I'm sorry. Requested by mommy. Oh, she's really kind of turning it on. Okay. All right, so we got our Netflix password. Okay. Now, when we look at the distribution, do you notice anything about the distribution of COVID change between 2020 or no, October, September and October 2020? Pretty normal, right? You got these outliers way out here where you probably had some outbreaks over here. But for the most part, it's just nice normal distribution skewed to the right a little bit, which I think is interesting. You know, we don't make this, we don't make this stuff up here. All right, so getting back to this, if I were to make this equal interval, okay, now equal interval, basically I have 5 classes that go from 0 to 389. I'm gonna have to do some math again, but 0 to 80 is in one class, 80 to 160, 160 to 240, 240 to 320, 320 to 389. Watch what happens. This is the same exact data. If I were to make this equal interval, what just happened in my map? Same exact data. I mapped it using a different technique. If someone turned in a map like this, or you showed this at a conference, what would people say? Why is Andy shaking his head?
It's not very good, probably because of.
We got these outliers that move everything. So essentially, this is like a 2-class map. It's got the first class and the second class, maybe 1 or 2 of the other, but it's just a 2-class map. Meaning quantile, every color is going to appear the same number of times. Those are the trade-offs where hey, one of those classes in my quantile takes up a really, really wide range where you got the 89 all the way up to the 389. But if I were to look at the height of these histograms, basically the height of these histograms accounts for the same amount, even though this amount takes up so much. Okay, so I really want to make you understand that you have the ultimate control and power with all of these. There's other methods. We've got equal interval. We got the standard deviation right here. The standard deviation might be thrown off a lot just because you got these outliers right here. It's got a little bit more contrast here, but not as much as the other one. So I feel good about that one here. But this is the position paper. The position paper here, you're going to see lots of kind of relationships between COVID and income and cars or whatever. So when you start looking at some of the zip code data, and if you really want to with this zip code data, you can click my little fields view right here. And I got tons of other things here that have gone unchecked, like number of vehicles, base population, average age, number of people 18 and over. I got these things called like bin changes, which I was doing for cluster analysis. But if you start kind of developing data from the position paper for something like this, feel free, more than free to ask. Median household income, I got a couple of median household incomes right here. Percent Democrat, percent Republican. And so those are some things that we extracted from the North Carolina voting database here. So maybe we can look at these, if you look at these like, hey, Democrats are largely rural. Like, maybe they're not, To me, with the COVID rates and the people we wrote, like independents were low COVID, high, send the stuff in by mail. Republican, Democrat, they were high either way, those independent voters. Mhm. So I thought that was kind of neat here. Let's give, we got a little bit of time. Let's check out exercise number 2. I just want to make sure we open it up. We're able to kind of get some of the questions I've got here. So I'm going to say no. Yes, that one. Yes, thank you. Okay, so we got, so for next week, we got exercise number 3. We got reading number 2 due in 2 weeks. So I'm not going to be doing 3 weeks. I'm sorry, because I'm not going to be here in 2 weeks. And then we've got Esri assignment number 2. This Esri assignment is called Space-Time Analysis, Finding Temporal Trends. And so today we're kind of talking about how do we change, how do we go from one time to the next? And to me, I kind of defer to Esri because they got a lot of neat tools on doing like maps that change colors over time if you have the right fields in place. And yeah, and if I remember right, Chima did something like that a long time ago, related to COVID. So I'm kind of, I'll defer to them on that. All right, so exercise 3. Those of you following along, here's exercise 3. We're going to download it. And I'm kind of doing the process as well here because I want to make sure everyone can do this. So I'm going to save it into my downloads. And here it is. Okay, from here, remember, and I've had a few people, probably about 5 or 6 people across my classes, if you start opening stuff up here, it's not going to work. Make sure you extract it and then extract it to your class or wherever you want to store it, flash drive or whatever. But for now, I'm just going to extract it here. This is a really big file for me. Okay, so make sure it's extracted. So now I know that it's uncompressed. How do I know this thing is already uncompressed? Because it doesn't tell me to extract file. Okay, while I'm here, I'm going to open up exercise 3. I've already opened it up before. And here it is. Okay, I got a couple of things here. I got a couple of questions. The need for normalizing data. When we map raw data, what's the problem with mapping data such as count or frequency? And you can put it into your own words, but what are some of the challenges of mapping just count data? If I were to map cancer deaths by county, what county is going to win or have the most in North Carolina? Largest ones. So essentially, you're just mapping where there's the most of anything. Okay, the most. We don't want that. We want to map rates. Another thing, and this is a little bit more nuanced with number 2, is according to the need for normalizing data, why do we want to map rates for number per thousand or 10,000 instead of per capita? What's the word per capita mean? Per person. Per person. So if I had a county here, we'll just look at Durham right here for the sake of argument here. Last year, they maybe had 50 homicides, right? I don't know if that's a good number. 50 homicides. What's the population of Durham? Let's say 350,000. What's that murder rate or whatever? What's the right word we want? Homicide rate per person. It's going to be a really, really, really small number. So I'm going to do 50 divided by 350. Oh, yuck. So 0.000014. And what does 0.0014 homicides look like? Yeah, I don't know. Now, what we can simply do is, let's just move the decimal point over 1, 2, 3, 4. So 1.4 sides for every 10 10,000 people. What does 10,000 people look like? All students, staff, and faculty on campus. So for every group of 10,000 people, this area has 1.4 homicides, where that Alamance County might have 3.2. Chatham County might have 0.7. Wake County might have 2.6. And so we can normalize these rates because we're just putting it into a context that we can understand. And I get really emotional about, or opinionated about making sure we use units that people from age 9 to age 99 can understand. And I don't think, even kind of learning people out there don't have trouble kind of understanding what 0.00000014 homicides per person looks like. All right. And I want to stress that because when you make your final maps right there, that's, you don't want to lose anyone there. Okay. All right, what else do we have? All right, exercise 3A. We could open up 3A for a little bit there. Okay. Oh, we got scatter plots. Okay. And we'll look at some scatter plots and then we'll make the maps right there. Okay. We probably won't make that map, but I'll kind of get a start. So if we got 3A right here, and I'll explain it real easy because I want you to make a map because really get in the habit of making high quality maps. There's some people in here that make good maps. Cameron makes better maps than me. I'm just, I don't have the attention to detail or the motivation or, you know what I mean, to sit down and do all the pretty stuff on it, because I kind of get to a point where I'm forget it. I'm just going to pop it to the web and I don't care. And, I get really mad about it. Okay. All right. So we got the map. Okay. We got layers. This looks kind of weird. This is kind of a weird map here. Okay. Yuck. Maybe I'll add a base map here. Oh no, I'm not sure what I'm doing here. So, all right. So we have this thing called joint counties, and Lamana had a question. She joined us online about making this here. But this is the joint counties when we run the spatial joint. So this is we're still back at exercise 1 that we've built on for exercise 2 that now we're building on for exercise 3. And so when I right mouse click, and I kind of went through the trouble of creating a separate feature class instead of the joined layer. And so when I open up the attribute table, because originally I've got all these cancer deaths sitting there. And who wants to look at this map here? What do you say about this, Will? Just too busy. It might be great for my little neighborhood to zoom in on it and see all the cancer deaths and maybe look at, point source pollution versus these cancer deaths. But this is just too much. And so what we did with that spatial join is we went through the trouble of counting the number of cancer deaths by county. And while we were there, I did something. Okay, while we were there, let me go back here. And you see I ran a whole bunch of statistics there. But I have something called a count. What do you think count is? Total number of cancer deaths. And then you can see I've got some X, some Y, min age, max age, all these other things here. So you could get an idea as to what I was doing. I think I just clicked collect all statistics. And previous incarnations of ArcGIS Pro, you would just click, you had to specify the statistics you wanted. It would give you everything instead of now with ArcGIS Pro, it gives you nothing. You got to specify, hey, average age, I want the age, I want to average that. I want to get them in, I want to get a max. So you can see some of the extraneous, garbage that it collects here. Now, for the first map, what I want us to do is just calculate the rate. What's it ask for? I'm looking. So we're going to calculate the rate per 1,000 people. Did we do that? Didn't we just do that for new column? And we'll go through and do that. I'll show a little scatter plot and then we'll kind of show us how to do scatter plots because I love scatter plots. Okay. So what we got here, I'm going to go to my fields view. I'm just going to do death rate. And I'm going to calculate this as a double. Okay, I'm going to calculate this as a double. Why? Because I want decimals here. I'm dividing by populations. So all I'm going to do is per capita death rate per county, multiply the whole thing times 1,000 so I can get the number of cancer death rates over this time period for every 1,000 people. And I'm going to click save. And I'm going to record this so if you need to go back and revisit this, because I want to get to the point where we make that scatter plot. Okay, so this is my fields view. So I got a brand new column. How do I calculate the death rate? What column represents the total number of deaths? Yep, exactly. So I got this count. What column represents the population? What are you going to say, Josh? Top what? Top 2013, I think. And then what do? We multiply the whole thing times 1,000. Make sure your Aunt Sally is happy about that. Okay. And so we right mouse click. We click calculate field. So what do? We just go in, look for the, so first thing I'm going to do 1,000 times that field called count, and then divide it by top 2013. That's all I'm going to do. Should I get a number more than 1,000? I'm doing it per 1,000. No, you can't have 1,000, 1,100 for every 1,000. Now, what kind of numbers? If you really want to hand jam them, you can calculate them, but I wouldn't worry about that. Who do we have? Death rates here. I got 18 all the way down to 6. So you can see like some counties have like 3 times higher death rates than other counties from cancer. 3 times higher. It's pretty interesting. And so we had some people go back and age grade that, maybe you want to age grade this. I wouldn't. It's not that bad to age grade. You know why? We already have the different age cohorts there, but you'd have to go through and get the age specific death rates, and that would get really ugly really quickly. There might be an indirect way to do that, but I'm not as much of a biostatistician as I pretend to be. So, all right. And if you really wanted to, what can we do? We can make a nice pretty map right here. So instead of single symbol, this is graduated colors. This is a fancy word for choropleth. Instead of mapping the object ID, I'll go down and map death rates. So here are my death rates right here. These are the death rates by cancer from the data that we were started with in week 1. So you notice we're kind of building on all this here. Really trying to tell some powerful stories. All right, next. And this is the thing that I wanted to do with us. We're going to make a scatter plot because I love scattered plots. And we're going to use these later when we start to look at something called regression. So I'm going to right mouse click. And I'm going to create a chart. Look at all the different charts here. Bar, line, histogram. We know what histograms are, right? We just get those from the statistics. scatter plot matrix. These are all different ways that you can visualize your data. So obviously we got maps here. We can visualize our data, but we have other ways to visualize them. So I'm going to right mouse click and I'm going to click on scatter plot. Scatter plot, for the most part, we are going to graph one variable versus the next. And so I got to remember how I did this before. Okay. So we're going to click on properties. And then what's the X and what's the Y? Remember back in math class, what's that thing? Y equals mx plus b. What's that? Slope and all that other good stuff. So we have dependent variable and independent variable. What's the dependent variable? I'm going to point our online folks right back here. Y, this, you know it's y equals mx plus b. So this y is called the independent variable. Y is the dependent variable. X is the independent variable because y depends on what x is, right? And so when we do regression, has anyone heard that term regression? We make these big fancy formulas. We have x1s and x2s and x3s and x4s and x5 to figure out what is the cause of what helps explain access to food or find male voting patterns. Is it income? Is it race? Is it morality? Is it access to transportation? All of these independent variables that come into it. Looks a little uglier than y equals mx plus b, but we just throw it into software. We throw it in ArcGIS Pro and let it do its work. So we got a nice little scatter plot right here. So we can have something like y equals 2x plus 3, and it's a nice little line with a slope of 2 and a y-intercept 3. All right, so to me, what we're going to do is our x-axis is going to be our average age. Oh, I'm sorry, median age. And our y-axis is going to be our death rate. What do you see here? And so we have the different counties, we have the median age, and the death rate. Look what it gave us, a nice little y equals mx plus b. Y equals negative 0.53 plus 0.44x. R squared equals 0.56. Anyone know what this R squared means? Well, I'll mention this in a little bit, but what happens for each county? And so if I were to kind of click on that county right there, I think I can do it. Need to find my mouse. But I can click on this county right there and look what happens. See this county right here this county right here? And this is, I believe it's Camden County or Currituck County right here. It's got a median age of about a little over 41, and it's got a death rate of about 9. Because these are different scales. This is years, this is per 1,000 people. And this kind of gets right to the beginning of our regression analysis. Now, this line means, this is what we call the line of best fit, meaning the distance between this point and this line has been minimized for all 100 of those points. And so when I have something called R squared, that R squared means that we can explain 56% of the death rates using age. So basically, as the age of the average age of each county. So these are the counties where there's older people. These are the counties where there's younger people. The death rate goes up. Does that make sense? Yes, because older people die. You know what I mean? That's why, and that's why I want to reinforce the idea of age grading. Hey, we need to age grade all of this stuff. Where that you got to probably go back to the original data, the original 100,000 deaths, and All right, let's get the age 0 to 20, 20 to 40, 40 to 60, 60, 60 to 80 and 80 to 100, and then get the age specific death rates for each county, and then and then weight those by the percentage of people who are 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So we got that right there. Now, the thing is, what's the other 44%? Because in theory, can I really predict it? No. Because if I could predict it, everything would be right on this line, right? Like your y equals 2x plus 3. If x equals 7, y is equal to 17. This is called the line of best fit. I like this stuff here. Now, we had a student probably about 6 or 7 years ago, where he did these models where he had multiple variables coming in different dimensions, where he was looking at the relationship between EOG scores and all of the socioeconomic indicators, age, race, whatever, where that EOG scores was your dependent variable, and all your independent variables, all these other income, age, race, ethnicity, everything else. And what he was looking specifically for was outliers. Basically, hey, let me look at these areas right here, which have low median age, these counties here, which are below the line. What does it mean if it's below the line? What's it mean if it's above the line? What's below the line mean? The death rate is what? Lower than what? What it's predicted to be. Okay? Because we got that little formula there. So that formula says if your county is 42, has a median age of 42, this is what your death rate should be. So these counties below it are less than what it's predicted to be based on this line of best fit. So these ones below are good, not good, but doing better than the ones above. And we're throwing out age grading. Okay, forget about the age grading, because throw that in, that's a totally different thing. But I think above and below the line, I think are pretty interesting as well. Because we've got some here that are above the line. What county is this over here? This county is above the line. It's young, but its death rate is higher than what you would expect. Robeson County, what's going on in Robeson County? Urban, rural, healthy, good things, bad things going on there? What? Who's from Robeson? Who's from down that way? Rural, backcountry, access to transportation less. So even though they're younger, they still have above what you'd expect. And I would bet you these counties right here are probably richer, higher income. And then these other counties probably aren't. Here we go. Chatham County. Okay, what's going on with Chatham County? That's like the new suburb of Raleigh. Try to find a house for under $1 million in Pittsburgh. Where's someone like? Where are you guys going to come up with $1 million? Hard, real hard. Where am I? Hard. People up there, sell their houses. Come on down here. But you've been to Pittsburgh, it's really nice. Especially the new parts they're building. Okay. And that's the kind of the eastern part of Chatham County that's commutable to Raleigh and Durham. But these are all areas where the death rates are less than what you would expect for that line. And we can turn that line into a curve, like y equals 2x squared plus 3x plus 4, something like that. And so that r squared goes up a little bit, but not that much. We're going to get more into these later. Okay, we'll get more into these later. Last thing I'll mention real quick, is like I said, I want to get out, but I kind of I get into these maps right here. So that's the first 3A, 3B. We're gonna do some change detection. And basically, what I want us to do, we're gonna do what we did last week, and we are gonna calculate percent change between two age cohorts, like 2015, 2016. I just want to open up this exercise and make sure I kind of have a understanding of what we've got here. So we have, and what I've done already, prep the data, is that we got cancer deaths for 2015, 2016, 2017 for each of these zip codes. So what you're going to do is we're going to do the same thing we did last week. Remember we did that summarize? And then we're going to get a column for 2015, just for each of these 80 zip codes. We're going to get a column for 2016 for these 80 zip codes. Then you're going to calculate the percent change. Because if something goes from 8 to 16, well, that's a 100% change, is the same as going from 4 to 8. So if we did raw change, well, what's going to be the raw change? The one with the 8 is going to be more, and no, even though they doubled up. And so you're going to calculate new columns for the 2015, 2016, or 2016 to 2017. I'll give you the choice. If you really wanted it, you can go to the coronary heart disease that we did last week. Now, remember, didn't we group it all together, if I remember correct? And I would refer to last week's lecture and us going through it to, hey, I want to get to 2015, I want to get to 2016, and then all we're going to do after that is just calculate the percent change. Right, so you went through the trouble of getting the 2015 stuff, you went through the trouble of calculating the 2016 stuff, and so we've got new, whole, divided by whole. To me, I always like multiplying it by 100 because I don't like 0.4. I want 40%. Okay. And so it's just whatever you calculated for 2015 minus 2016. 2015 divided by 2015. And then multiply it all. Now, you're going to run into, and you'll notice that I do ask some questions about small number problems where like you might go from 0 to 1. What happens if you go from 0 to 1? What value is this going to calculate at? If you go from 0 to 1, if you go from, let me draw this a little bit better. So 1 minus 0 divided by 0 times 100. What percent change is that? You go from 0 to 1. What did you say, Michael? 100%? You sure? I heard some hundreds. What's 1 minus 0? That's 1. What's this? What's all this stuff divided by 0 equal to? What's all this stuff divided by 0? Infinite, that's nothing. Yuck, bad. Okay? Why? Because you can't divide anything by 0. Like it's infinite, no data, whatever. So be careful when you calculate this because ArcGIS Pro is going to yell at you like, hey, I can't do this calculation. It might put something like NaN, meaning not a number. And so be able to look out for some of those warnings there. If you go from 0 to 2, not going to work. Now, the other way, if you go from 2 to 0, it's going to calculate it. It's going to be like a 200% decrease or whatever it is. But if you go, if this denominator is equal to 0, or be a negative, you go 2 to 0. So you go from 0 to 1, you're going to have a problem. You go from 1 to 0, not as much of a problem because that 1, that whole, that 1 to 0, one's going to be in the denominator. So it'll be like, I think it'll be a negative. Yeah, 0 minus 1 will be like negative 100%. It's gone down. So be aware of some of those caveats. Get an idea as to what the right answer looks like. So what I'm gonna encourage is refer to last week, just do get a column for, just call it deaths 2016, 2015. Get a deaths 2016, and then get a percent change. And then all you'll do is just apply this formula. Now, you got a little work ahead of you too. I gotta extract all these things out, because if I were to look at this cancer deaths for 2016, and I open this thing up, we're looking at all the cancer deaths in North Carolina. So remember what we did last week was, we ran the nice little summarize. After we ran the summarize, we just joined it to the zip codes. We joined it to the zip codes and did what? And then it only kept anything that had a zip code in our study area. So 27358, where I live, it's not going to be part of this map because I don't have it here. So when you run this summarize, you might get, 700, you might get 723 of these. You might, get 723 of these. Right? So that's pretty good. Okay. So I'm kind of leaving you to kind of work on this. We did the first part with the A. You got to do a couple things to clean it up. This B here is going to be kind of building up from last week and go from there. So I guess my wife, she just told me that mortgage rates are lowest since 2003. So I don't know what she's trying to tell me. I don't know if that's code for something. I hope I don't have to open the wall. Okay. All right, so any questions for me? All right, be on the lookout. I probably won't be able to post this for a day or two, so I'll see everyone. We got Esri exercise, and this exercise will be due next week. And then after next week, we'll take a week off because I'll be gone. So see you all later, and that's about it.
Thank you, Mr. Maroney.
All right, see you later.